So the topic, of course, for today was Firstbeat's how it boosted productivity for heart rate variability analytics, and of course, being excited Finn here in the front of you guys. So it's heart rate variability, kind of feels like a right thing to do. So welcome to lovely Helsinki. Also the people from other Nordic countries, and of course the people from Finland as well. So here we are kicking off the series of shortest talks. So this is about a 25-minute talk, roughly. Let's see how well I do. I think Pekka will give me signs that you're running over time. But for that reason, since we're running about 25 minutes, if it's okay, let's skip the questions, and then I'll be here all day. So if you want to talk about something specific, we can do it after the show and this presentation. Unfortunately, the people from Firstbeat couldn't participate today. It would have been really awesome to get their awesome team here on the stage, but unfortunately today wasn't possible for them. So you're kind of stuck with me. Hopefully we can all survive that today. So a little bit about our background. So my name is Janne Kuha. I work for a company called NodeHero. And we kind of are DevOps, data engineering, and serverless solutions. But the idea is that we are a consultancy company for AWS, and of course worked with Firstbeat for a long time. And this is something I'm really passionate about cloud architecture and AWS. So I know a Finn excited about something and passionate. It's really an oxymoron, but I guess we'll do it this time. But really about the talk itself. So I don't know if you guys heard of Firstbeat. Quite a lot of people in Finland have. It's a leading provider of this physiological analytics for sports and wellness. So they've been in the business for over 20 years. So they started in 2002 in Jyväskylä, actually, which is my hometown as well. And Jyväskylä is sort of this hub of sports and sports-related sciences here in Finland. And even though you might have not heard the name, their technology is used by hundreds of elite sports teams, millions of customers, because if you have like a watch that's measuring your heart rate, some of these brands are using their technology. But first and foremost, how I see Firstbeat, of course, they would be the best to describe themselves, but I see them as a science-based company. So they've been doing this for 20 years, and they are really a pioneer in heart rate variability analysis. So when your heart rate is varying, they know how to read stuff out of that and other factors as well. So they're kind of known for at this point for a lot of things, but like two major areas, which is the Firstbeat Life, which is kind of the leading platform for wellness, for wellness services, and companies like Mehiläinen or Terveystalo Opiskelijalinna are using their services as well. And the other part is the Firstbeat Sport, which is optimizing training, optimizing recovery, getting to know what the athlete's body is doing while they train. And for this as well, I mean, even though you might not have heard of the company, or you might have heard them, but it's used from anywhere from national hockey team of Finland to soccer FC Bayern Munich or something like Manchester United. So they're quite well known in this space. So that's a bit of a background of the stuff that Firstbeat does, and today what we are looking at is one specific area of this thing. And as I mentioned earlier, they are really science-based. Because you have heart rate variability, you can analyze body stress, for instance, recovery from stress, like how the body is functioning, and yet that can be utilized for well-being and sports and other similar things. And since it's science-based, the thing that Firstbeat has to take care of is that it's very, very high reliability and consistency of the analytical results, right? Because you need to do it in a way that's sustainable. And as you can imagine, this type of analytics and this type of business creates a lot of data. So, over 100 billion heartbeats analyzed. So that's quite a lot of data. And they've been in a lot of scientific lab projects and publications, and since they've been doing this for a while, they're really known in this space. And one of the challenges, of course, doing this for a long time is that when you have new analytical, the stuff measuring your heartbeat and deriving results from it, if you take new algorithms into use, right? If you take a new algorithm that's been improved or takes some more data or is somehow better than the last one, you kind of have to know if it's better, right? Like if you do unit testing on your code, that is it still green, right? But you have to do this kind of over 100 billion heartbeats or something like that. So the idea is that you have to test it, the new algorithm or the new algorithms or the versions or the different parameters in different, over the whole data set, right? To get an idea whether it's working as expected and as good as the previous one, right? So this was kind of the challenge that we tackled jointly with the Firstbeat team, right? They have an excellent software and analytics team, of course, and we were really, really honored to join them in developing this solution at Node Hero. But the challenge was with the existing infrastructure and existing solution that it really took 4 to 5 days to get this on-premises service running through this analytical data, right? And if you can imagine that, you work on Monday and there's a great new algorithm, I'm gonna try it out. And on Saturday morning you go and, it didn't work. Let's try it again on Monday. So that's really, if you think about the speed of innovation, that's really not an ideal solution, right? So as you can see from Tero Myllymäki's comments, who's head of physiology research at Firstbeat Technologies, it really didn't, it wasn't an optimal solution. It worked, but it wasn't optimal in a way. And they were using cloud a lot. They utilized the cloud in other services extensively, and we've been, of course, working for them at that time already for quite a while. And they kind of presented us with this challenge that how do we move to the cloud, and could we do something about the speed of innovation, the speed that we can get these new algorithms or a new data sets into the product. So we jointly started figuring out that what could we do, what's the possibilities that we have, and we kind of came up with this approach. Even though, of course, there are risks when you don't do a direct lift and shift, you re-engineer and you really think about how could we do this in the cloud in AWS, and we decided that it was jointly. We decided that it was definitely worth a risk, to go from the existing, not just move the servers over to the cloud, but really think about the architecture itself. And what we kind of came up with is it's small serverless footprint and massive scalability is what we are looking for, because that's what the cloud is good at. Before we go to the actual solution itself, I thought we'd take a look at a little bit of the technology behind it. Then we can kind of go through the technological steps that we took and kind of talk about them and figure out together what we kind of did. But the technologies used are roughly here, a bit oversimplified, of course, because there was a lot of other nicks and knacks that we used, of course, but kind of I'll give you the broad idea. So AWS Glue, if you're not familiar with it, I'm not sure if, are you guys familiar with it? Some are nodding, some are like maybe. So let's quickly go through this. So AWS Glue is like a serverless way to process big data. That's kind of it. So the idea is that you feed in big data, and because the fully managed serverless solution, you really can. It's like an ETL kind of a tool. So you can source transform, and then store it up as needed. And it's running on Spark. So the basic Glue service is Spark cluster, basically. So you have something like Amazon EMR, which is less serverless in this space as well. Then you have something like AWS Batch, and it sounds a bit. It has maybe I don't know how it rings to your ears, But batch processing sounds kind of like batch processing. What are you guys doing? But it's actually a really cool service for this type of work where you do life sciences or you do, let's say, genomics research or something like that. Because the idea is that it's not if you have something that's in a container, right, in a service that you build yourself, it would be kind of difficult to transform that into a AWS Glue job, right? Because you have custom code, you need to run a custom container, a mini computer, if you'd like. And AWS Batch is really, really good at running a lot of these containers at the same time and optimizing the queue for these resources, right? So the idea, you push in tasks and you get a lot of these tasks into the AWS Batch, and then it kind of figures out that how many containers do we need concurrently? Is there a prioritization in this queue? Does this batch job depend on that batch job? And it's kind of running it on massive scale if needed. And if you use AWS Fargate, sorry about the Finnish version, AWS, sorry, for our internationals here. If you use it with AWS Batch, you can run it fully serverless. So AWS Glue is serverless, AWS Batch is serverless with Fargate. So you don't kind of need to worry about how the containers are running. It takes care of that for you. If you have a single service such as Glue, you could of course have the workflow inside the Glue itself, or if you had AWS Batch, you could have kind of the workflow inside AWS Batch. But since we are combining multiple services, including Glue, Batch, and Athena and QuickSites, we kind of need to glue it together, right? Kind of make a workflow out of it. And AWS Step Functions is the workflow tool in AWS. So to combine multiple AWS services, AWS Step Functions is a great tool for that. But since we are using multiple services, we needed to use something that's not inside one tool, but multiple can accommodate for multiple tools. And we wanted to have, of course, the visibility to the data as early as possible. So the Amazon Athena, based on Presto, is a really great tool for that. So if you haven't used Athena, I strongly recommend trying it out, because it's kind of having a database and a query language on top of files, which is really, really cool. So you have files in S3, whether it's JSON, CSV, or something that's really optimized for this, which would be Parquet or ORC. Then you can use something like Athena and query the data. And it really doesn't matter if you have gigabytes or terabytes of the data. You can still handle that. So you can imagine that you're running SQL queries on top of files. And then finally, a couple of tools that we use. One is the QuickSites, which is the kind of the BI tool in AWS space. So to visualize the data, to quickly show it to necessary people, you get it as AWS QuickSites for that as well. So that kind of brings us the technologies used for this kind of talk. And then we can go in and actually see how some of this stuff was used to build the solution. And of course, S3 for storing the data, but that I guess everybody's familiar with. So let's start with something, the first step, and what I'll be talking about here is really the kind of the getting the source data, which is the S3 and maybe some RDS as well, getting that into a format that's really usable in the later phases of the process, right? So what you have here is S3, including it could be raw data, it could be CSVs, it could be JSONs, it could be something a bit more sophisticated. But the idea is that you use Glue. We used Glue as the pre-processing tool, right, to get the data into a correct format. And you could do two great things with it. One is you could, of course, transform it into Parquet files, right, which are a lot better to read from a technical standpoint than JSONs or CSVs or something like that. So we could transform it into Parquet files. The other option would have been ORC files, but we used Parquet files here. And you could also augment the data, right? So if in the incoming data there was something we wanted to add to the data as part of the processing, let's say it's some measurement we get from another source, or something that we get from somewhere where it's not in the file itself, then we could use this Glue to basically glue that stuff together. That's, I guess, Glue. Perfect. So the idea is that we could transform it and augment the data as well as write it out to a proper data source, or a S3 in this case. And we could do the same with RDS. And somebody might ask, so why don't you just read directly from the RDS? And we could have done it as well, but it's a lot better and a lot faster to get the data into the same format as from the topmost processing pipeline. We could get it into the same format with the lower pipeline. And what that did is we have two sets of data, or multiple sets of data in real life, of course, that we could kind of work with in a really efficient way. We did use Amazon EMR for specific cases, because Glue, even though it's a great tool, it's a perfect tool, of course, being in an AWS kind of a conference. There are, edge cases where it's not perfect. With Amazon EMR, if you run a Spark cluster, you can define the cluster size and the machines and everything more specifically, or more tuned to your workloads rather than Glue. So we had to use Amazon EMR for certain cases, but those were really the kind of edge cases. And of course, if you run the data once, then you might not need to run it quite that often again. What was great about this, or what was really nice about this solution, was that you already at this point, you already have the data. You can already query the data, right? So now it's in S3, it's in Parquet files, and you can run SQL queries on top of the data just by running Amazon Athena, right? And you can build these meta tables or metadata catalog, that what data is where, what's inside each file. If you need to find a specific record, then what's, in this file it's from this to this record, in the next one is from here to here. So it's really, really fast to run these queries. I mean, 1 second and you have the results, basically, which is really, really kind of amazing. And Athena is based on the open source Apache Presto, so it's quite well-known technology. So this was the pre-processing step. This is how to get the data in. And the next step was, how do we actually then do the magic? How do we process multiple algorithms at the same time on the data? And so what we had is the AWS Step Functions workflow that we used. And that we used for getting the data in, and then kind of reacting to these files coming in. Of course, we could manually trigger it as necessary. We could automatically trigger it based on the incoming files in S3, or we could, we had multiple ways of doing this. But the idea is that you have a step functions workflow that then takes care of, the incoming data, feeding in it to the AWS Batch, to the queues, and selecting what algorithms need to be, in this case, in the reanalysis phase, right? How to reanalyze the data. And then, of course, we used something like DynamoDB for the workflow control. There are certain steps where we needed to record that we've done this, but we haven't done that. Okay, that failed for some reason. We need to, it was a lot easier to have some of this data in DynamoDB, but it was just used for workflow control rather than, storing any data to it in any meaningful way. So the idea is that you have Lambdas that kind of control and the workflow, and then you have in the center, you have the AWS Batch. And what that is doing, it's seeing what stuff gets into the queue and how much of the queue is requested, right? So you have 1,000 things in the queue, then it spins up more containers at the same time, rather than if you have like one task in the queue, then it's just, just one container, right? Or similar to that. So the idea is that with this we could do in a way that we have massive parallelism with the tasks, right? These mini containers, these mini computers running at the same time, and what we could do is really have scalability on top of these files. And why did we use Batch instead of Glue for this? Is because we need to have custom containers. We need to really run it through a custom thing that could be only run in containers. And I think the limit is somewhere, don't quote me because I'm not sure about this, but I think it was something around 1,000 concurrent containers running at the same time, or the easiest Fargate tasks you have on one single account, minus a few tasks which are reserved for AWS use. But roughly, to give you like a sense of scale, you could roughly run 1,000 mini computers at the same time if you needed to. And then finally, again, we get back to them in Parquet files. We decided to write them out in Parquet files, which are then added again back to the AWS Glue. And we could, again, crawl these files, do stuff post-processing on them, combine again some stuff, some data into them, and then fill it back into the post-process data, right? So we have, again, the Athena as part of the data analytics. So now you can compare with SQL, like what was this before and what was this after the change. Of course, you need the containers somehow in, right? Just to kind of wrap this up. You need the containers built somehow, right? So what we use this Elastic Container Registry with code artifact and then a custom pipeline that produced these images, the containers that the batch was running, right? To get the correct type of algorithms and correct combinations in. As well as, we wanted to visualize the data. And because Athena can be a data source for multiple BI products, including the QuickSights, what we could do is, run data visualization on top of the Athena queries, right? So we could see the whole data sets and on all the data comparisons in real life. And there could be also, data scientists, data engineers, but as well as less data inclined business users that could see the data and react to it, to see new business opportunities based on the things that we found out in the data and visualize. And then finally, of course, we needed to take care of the problems that we had. Of course, we didn't have any problems, of course, maybe a few along the way. But the idea was that then you have, Event Bridge for monitoring the failed jobs. So if a job failed, we could get a direct Slack notification out of it. Or if you had something running out of budget or, in a way doing something that it shouldn't do, then we connected budget to chatbot and get that Slack in notifications as well for those. So we could control the budgets as well. So roughly this is the solution that we kind of built. And of course the interesting stuff is, did it work? So this is a cool slide. Now what happens? And ta-da! What was great that Tero mentioned exponential difference. So it sounds like really exciting for a Finn. But the actual real life result, the end result was that we could run this 4 to 5 day job in less than an hour. Before we added data to it, because of course once we saw that it kind of works really nicely, we started adding more and more and more data, and we still could keep it in a very short time span. But the first test that we did with the data was kind of encouraging, because we were like, did it finish already? Did it go through? No, it didn't go through. It couldn't go through this fast. And then you're like, it did go through. Kind of cool. Like having it in so fast. But the end result was that, with something, using the cloud to its benefits, right? Massive scalability, serverless, no need to manage anything in the sort of from a computer or a VM perspective. You had all this stuff running serverlessly. You could build it with CDK, for instance, with IAC, so infrastructure as code, so nothing needs to be configured manually. You could pop it up to another account if you needed to test it out. So each developer could have a copy of this whole infrastructure on their account in, let's say, 10 minutes. And the end result that what we didn't expect actually was that we thought it would be a bit more expensive, but it turned out that running, hundreds of containers, but running them only for a short time is actually quite cheap. So a few euros per run. So that's it. That's my 25 minutes and 17 seconds. I thank you for the stuff. And if you have any questions or anything, I'll let the next speaker come in, and I'll be right there to answer any questions or thank you.